Let us discuss this result. See, this result says if function is differentiable on an open interval AB and if its derivative is greater than 0 throughout interval AB, then f is increasing function. This is a very important result when we solve problems. Getting what it says, if derivative is positive, definitely the function is increasing. This thing we have to prove. So let us start with the given information which you have already written here. What is the given information? Function is differentiable on open interval AB. If it is differentiable on open interval AB, it is differentiable at each and every point of open interval AB. So that's why I written function is differentiable for all x belongs to open interval AB. So therefore we can assume, f dash of x is equal to L, I am assuming, for some x belongs to open interval AB. Function is differentiable, that means derivative exists. So f dash of x exists and we are calling it as L, okay. But the information is f dash of x is greater than 0. So and we have assumed f dash of x is equal to L. So obviously our L is greater than 0. Tell me, still you remember the definition of derivative or differentiability which you already studied in 12th standard? So that definition I am going to write. So that definition is therefore limit h tends to 0 f of x plus h minus f of x divided by h, which is equal to L. Simply a 12th standard definition I have written here. So with the help of limit we have defined derivative. So the same thing we can express in terms of epsilon and delta also. By definition of limit we can write, okay. So by definition of that epsilon delta, what can we write? Will you tell me? So therefore for actually the beginning is for given epsilon greater than 0. Epsilon we can take anything. So here I am taking epsilon is equal to L. This is an adjustment, okay. So for epsilon is equal to L, and you know that our L is greater than 0, there exists delta greater than 0 such that so let us write on this side. What can we write? 0 less than mod. See, we have 2 points, x plus h and x. So yeah, second point minus first point, that means x plus h minus x less than delta implies, what can we write? Mod this term minus L. So mod f of x plus h minus f of x divided by h minus L less than epsilon. Simply I use the definition of limit. Getting? Just functions are different, that's why it is looking different. Let us simplify it further. What will happen? This x and minus x will get cancelled to each other. So therefore finally we will have, therefore 0 less than mod h less than delta implies. See, one result is there. Yeah, so I hope still you remember, minus a less than b less than a if and only if mod b less than a. So this result which you already studied, right? So this result I am going to use here. What can we write? So here this is this term is nothing but b and this epsilon is nothing but a. So let us use this result. What can we write? Minus epsilon less than f of x plus h minus f of x divided by h minus L less than epsilon. This thing we have got, okay. So this implies, what will I do? See, actually two inequalities we have, we are not interested in less than epsilon. I will forget it, just I will focus on this part. So what can we write? Minus epsilon less than f of x plus h minus f of x divided by h minus L, okay. So let us go further. So what will I do? I am going to shift this minus L on this side. Actually L has a minus sign there, if you shift it here it will have a plus sign. So therefore implies L will have positive sign, minus epsilon less than f of x plus h minus f of x divided by h, okay. So let me remove that part and after that we will go further, okay. Okay, it is removed now. So tell me, what is value of epsilon? Our choice of epsilon is L. Getting? So I can put epsilon is equal to L here. So what will happen, that L and minus L will get cancelled to each other. So therefore we will have 0 less than f of x plus h minus f of x divided by h. I will call it as inequality number star. So this is a very important thing we have got. But see, when you solve further, again there will be two cases. The first case is h is positive and the second case is h is negative. We will discuss both cases and let us come to the conclusion. Okay, so make a screenshot of this part. After that we will go further. Let us discuss first case now. The case 1 is h is positive. See what will happen if h is positive. What I am going to write? Then star becomes. See, I am going to multiply both sides by h. But h is positive, so that if you multiply both sides by positive real number, the inequality will be same. If you multiply 0 by h, so you will have 0 less than, and if you multiply this right hand side by h and h will get cancelled and we will have f of x plus h minus f of x. After that, what will I do? I am going to shift f of x on this side. It has a minus sign. If you shift it here, it will have plus sign. So therefore, f of x less than f of x plus h. The very important inequality we have got, I am calling it as 1. See, the first case is over here. So obviously the second case is h is negative. Let us discuss it now. Case number 2, h is less than 0. Okay. So from star, see what I am going to do. So I am going to multiply both sides by h. Okay, both sides by h. So what will happen? But h is negative, so that's why inequality will get changed. Getting? So therefore 0 into h we will have 0 greater than f of x plus h minus f of x. So inequality will get changed. H will get cancelled again, but h is negative, so that's why inequality will get changed. So then what will I do? So here I will mention h is negative, so therefore h is equal to minus k for some k is positive real number. Okay, so h is negative. H is negative, that means it can be minus 2. Getting? My negative number means minus 3, minus 2. So what is meaning of negative? Negative, that means actually the original number is positive. We are simply writing minus sign there. So we have a negative number. So h is also negative. So h is equal to minus of some positive real number. So the same thing I have written here. So let us put its value here. So what will happen? 0, therefore 0 less than greater than f of x minus k minus f of x. Okay, so let us shift f of x on this side. So therefore f of x greater than f of x minus k. Let me remove this one, it is not required now. Okay, so therefore f of x minus k less than f of x. The same thing I have written, but I have written in the proper way. Okay, so k is one variable. You can write k, you can write h, whatever you want. So I am replacing k by h. Replacing k by h. So what will you have? F of x minus h less than f of x. So I will say this is inequality number 2. So let us combine 1 and 2. From 1 and 2, what we get? F of x minus h less than f of x, right? Less than, but f of x is less than f of x plus h. F of x plus h, and it is true for all x belongs to open interval AB. Getting? So that's why we get this one. So but this is definition of increasing function. So therefore we can write, therefore f is increasing on open interval AB. So in this way we proved, yes, if derivative of any function is positive, then function is 101% increasing function. So after that, next result we are going to discuss. Make a screenshot of it and then we will go further. See, this is our next result. This result is same as the previous one. This result says if the function is differentiable and if the derivative is negative, then function is a decreasing function. So in previous result, what we have seen, if function is differentiable and derivative is positive, it is increasing. This result says if the derivative is negative, function is decreasing. The proof is same as the previous one. So I am giving this proof as an exercise for you So make a screenshot of it and then we will stop. Thank you. Bye bye.